this AI Driving Olympics competition is an excellent way to benchmark all of the different types and styles of algorithms that are used in self-driving cars. The AI Driving Olympics uses the Duckytown platform, which is a scaled-down autonomous car mobility-on-demand service for rubber ducks. The Duckytown platform was originally developed at MIT, but is now used for education and research and outreach around the world for all levels to teach them about self-driving cars and robotics in general. We view this platform as a stepping stone in between a simulator and the real world. Obviously, this environment is not as complex as the real world, but I would argue that if your algorithm doesn't work on this simplified environment, then it has very little chance of working in the complex real-world environment. At this particular version of the AI Driving Olympics, we have 3 different challenges. One is just following a lane, and the robots that can go the furthest without driving off the road will win. The second challenge, which is slightly more difficult, is following a lane with other robots moving around. And then this is actually the most challenging, where an agent should navigate through this road network that has intersections and also other vehicles. So what the robots are running right now is our baseline solution that we provide open source for competitors to get started. It runs the robot operating system, which is a standard robotics software framework. For competitors, they can use our open source code to start with, or they can choose to do their own thing completely. And we provide other baseline implementations and templates for them to get started if they don't want to use our code base. And I think one of the interesting things about this competition is that we can pit the more classical approaches to solving this problem, which are more engineering based, against the sort of newer, more deep learning and machine learning based approaches. But we can compare them on this very standardized, reproducible framework. We've made a huge effort to build software and hardware infrastructure so that people can compete in the competition and write their algorithms with the minimum barrier of entry, both in terms of building the hardware and in terms of the software requirements that they need to adhere to. The way that you get started running the competition is extremely straightforward. So you can get a robot. With 1 line of code, you can evaluate your submission in our on the cloud against our simulator. With 1 line of code, you can send your submission to our Robotarium, which runs in a lab in Zurich, but soon there'll be more around the world. And then with 1 more line of code, you can send your submission to the robot and actually evaluate your submission on the real robot and see how it does. Tomorrow, we're going to run all of the best submissions at the finals event. May the best DuckyBot win. This version of the competition is really targeted towards the graduate student level. We're planning to run these types of events for high school students and undergraduate contexts as well.